Okay, so this is really impromptu, but it happened at work, which I just got out of, and I was like, oh, I want to talk about it. So I am. So, I forget, actually, let me write down this name real quick. Motor on recruitment. And then the x-axis would be size, and then effort would be y-axis. Okay, so I forgot the name of this chart. I did, but it is the symbolizes motor neuron. It's not motor neuron. Motor unit recruitment by size. So as effort increases, size also increases. And you can see it's not a perfect one-to-one, but it is a size trend. So down here, where there's a little bit of effort, it's very small motor units. Here, where there's really big effort, a large amount of effort, there's really big motor units. And it's a bit of a ooh, shit. You didn't hear that. But it's a bit of a gradient. So, how this relates to what I was doing is because I got finessed hard by a coworker. I dropped my. She was like, "Hey, can you take out trash for us? Day shift didn't do it." I'm like, "Yeah, sure, I don't mind. I like take out trash for that department every now and then." But I never did it when it was night shift trash and morning shift trash. The amount of trash I took out weighed more than me, which is not that impressive considering I'm not that heavy. But it was well over 150 pounds of trash I had to throw out by myself, which was fun. But how this relates to this, I'm like, I know I have a couple videos on here that weren't strictly exercises. I would probably just tack them on at the end, is what I was thinking. Um, but I just wanted to explain this, the science. So, as I picked up a small, because all the trash bags were different sizes, and well, they were the same size trash bag, but they had a different amount of trash in them, so they were different weights. So as I picked up a trash bag with a little bit of weight, it would have been more here towards this end of the chart, where I would have been using smaller motor units to lift the trash bag out of the trash can. But then there was about 3 bags, which would have been on this side of the chart, where they were very, very heavy, and all 3 of them whipped as I was pulling them out of the trash can. So I'm sorry, I'm not. I'm using like the overhead light in my car. So so as I was lifting those, they required a lot more effort, and because of that, my body used a lot bigger of motor units to accomplish the job. In fact, in some of the cases, it was, I believe the trash bag was lighter than it was going to be. So I started off with one of these motor units down here, a weaker, smaller motor unit, really. Because the motor units themselves have about the same relative strength. It's just the fact that there's more muscle fibers per motor unit is what makes a difference. So, we started off at a smaller motor unit. But as I realized, hey, this bag is actually really heavy. I'm going to need to use more effort to lift this bag. It shifted upwards on the chart, and I started using more motor units, or larger motor units, sometimes more, because you often would use a combination of motor units and not just one. But the trend of the chart still applies, where I started using larger motor units to be able to lift the weight trash bag out of the trash can. So, as I mentioned earlier, I forgot the name of this chart. I know the chart has a name, and I'm pretty sure it's named after the guy who founded it, but it represents the motor neuron recruitment by size and effort. And like one more time, as more effort is needed, the size of the motor unit increases. So yeah, just be a really quick one, just because it popped into my head as I was taking out the trash today.